Today we go to alternating currents, chapter 2 of unit 4. As we have already discussed chapter 1, now we can move over to chapter 2, which is alternating currents. Alternating the meeting the alternating the kalam thiem ve chilova alternating in kalam meeting dona nui sẽ từ click nằm chân lưu nui tập về là với chuông là và chuan AC kan ti hian alternating ti chu in ka thla ka zela tin an meta am zo tong tak chuan enga tinge in alternating kan ti na chan kan ti chuan alternating chu với khata sanga với khata aniama asang aniama so asang le sang kara niam phong về zel ta ni mi va alternating kan ti kan meta. Then alternating current or EMF can be represented by this type of equation. We can have two types of equations. One is sine equation, sine waves, and another is cosine waves. Then this I can be replaced with E. E stands for EMF. It's a potential difference. Kan ti khania chuan like E naught I here, E naught I can write the SC equation for EMF like this: E equal to E naught sine or cos omega t. Here omega is angular frequency given by this equation. Angular frequency means in 1 second how many times this AC wave can complete one rotation. That means for one rotation, time starts from 0, here is 0, and this is half time. That means semicircle, half circle. This is another half circle, this half circle. Then if we add these two circles, we can get full circles. That will be full time. That is time period. Full time is time period. How many revolutions or how many full time of circle or full time can a current make in 1 second? Angular frequency and the Chuan like F is frequency, so 1 by time. Can make the 1 by time. So since we have the time and we have time 1 by time. That means what are alternating currents? That let us try to define. Alternating currents are the type of currents. It's really type of currents which changes their magnitude with respect to time, or which changes their magnitude as time changes. The kind of alternating current can be do we have any other current which doesn't change with time? Yes, of course. They are DC direct current. They are not a wave equation. There's just a straight line. Like wave straight line. DC stands for direct current, which we usually obtain from battery. Pencil battery in the current and the DC and the so here the wave start from origin 0. That means sine equation. His sine his sine equation. So if we compare these two equations, the first one starts from 0 and the first one starts from maximum. That means maximum when time is equal to 0, it starts from maximum, and it's entire t cos t 0 and its own cos 0 is 1 equal to I naught is maximum value of current in a big value in the current, and its own cosine wave here sine wave. Then if I draw another straight line here, then the whole of this can be considered as a sine wave. ai dan se tro ka cosine le sine wave dang lam khani chuan he tak tira ka sei dong khan he tian e equation hi ka zia ve ve the and they represent both alternating current EMF equation. So the most important part, let me say, is mean value or average value. Mean value means here tayo entire ito ki n chuan hi mark say to come. This is the upper part, half circle, semicircle. This is lower circle. This is its area is 5 plus 5. This area is minus 5. Let's suppose this one. Then if I add minus 5, let me try to find the mean value. It always equals to 0. This implies that if when we try to find out the mean value of SC, it cannot use general formula or finding average value. So therefore we will adopt another method or definitions. We need another definitions to find the average value of SC. So this is this part is the definitions. Now to find the mean or average value of SC, let us consider this type of coil in the simplest form of heater and make down. Chuan tuna chuan first part chuan ta hian let me connect these two ends with SC. This is SC. SC there. Chuan in the next part let me connect here battery tina here SC here DC. DC current for 10 seconds. Suppose 10 seconds times 10 seconds. This DC current sends 100 coulomb of charge to this heater. Like 10 seconds is half. Let this 10 seconds be half period of the DC SC. Chú mình giờ chú thì hiện wave khakal ta he lại wave hi high half period hi 10 seconds này. Full time ha 20 seconds này because half time is 10, so full time will be 20. If I pass DC current to this coil for 10 seconds, then this DC source EMF battery, let me say battery, sends 100 coulomb charge to this coil. So then I disconnect this DC source. Let me disconnect this DC source. Now we disconnect. So now we disconnect. Let me disconnect this DC source. I just only connect SC. So I'll pass SC current for same time 10 seconds. 10 seconds. So in 10 seconds how much current shall I need to send a charge of 100 coulomb to this coil? That much of current is called mean value of SC. 10 seconds SC 10 seconds ko on liang. So exact current nge 100 coulomb ki keng chou thiang heta chidoran ka pass thiang ti khami current ka mo zat kha min value of AC kan ti chuni chuan root mean square value kan kal liam root mean square value kan ti chuan tuni min kha in ang deuh chi a root mean square kan ti heta thu kale taila DC current hi let me say for 10 seconds I pass DC current to this coil for 10 seconds tuna chuan lahi will not consider charge will consider heat H joule. This DC current which is passing through this coil for 10 seconds produce suppose 100 joule of heat. Now I'll disconnect the DC source and I'll connect AC source to this coil and will pass the current for 10 seconds. Then the amount of current needed to produce 100 joule of heat for 10 seconds is called root mean square value of AC anti-tuning. Root mean square value of AC anti-taka. Kaka definition like tunia. A definition tete ka. Kan siya kan fil tam takha derivation pati awesome. Pathin evangin kai te ka koron remind le du chiwa. Chuan heta phasor diagram kan kalyang. Phasor anti chuan a quantity which can represented in a particular diagram to phasor anti chune. Now in this chapter we'll consider this circular diagram as this E and I is phasor. That is the quantity are phasor. Then E and I, though they are not a vector, we can represent it in a circular form. This circular form or diagram is called phasor diagram. Achan chu current chu ti hian current chu ti hian ka wave and current to ka wave and ka chon he semicircle. Then if I add these two circles I get full circle. A full circle kan ti ka ti thau bokan EMF ti ha kal ve thau kan he ti lai ti na he E ni ta se chuan he I anti khani chuanin tuna hian they move in anti-clockwise direction heta omega ko they are moving in this direction suppose the anti-clockwise in kalta anni chuan hian awesome do kan zia ka lenga hian this as I or this as E, but they are moving in one let the lie omega t angle and the thin khani omega t actually kami EMF equation khan en taila I equal to omega t omta theta tinari sin theta tinang khan theta angle sin ta so the difference between the angle between E and I or I and E is called phase angle. Okay, phase angle ani phase angle tani tuna hian E hi I ma a kal mek tani chu E lit I anti khani E lit I anti da so by face angle phi đi face angle phi and it's on if phi is equal to 0 means this I and E are in the same line they are in the same line, that means they are in the same phase so and if E and I are in opposite, they are out of phase. That means they are moving out of phase. So suppose this is I and this is E. That means I leads E by phase angle phi. Phase angle light there. So tai là thì han đủ to clock là next sa son hi sei chun som le don ya a video ya sei the a sai san lin tu chun download vela a boi thak de me thing ta thì khan đủ to ri phat me